Hello, this is a help video for 5.11 unit test part 2, the teacher graded assignment. I have made up my own graphs for number 1 and number 2. So these are not the graphs that are on the TGA itself. And then I've also made up a problem for number 3. So I'm going to go through these fairly quickly. Again, this is not the exact problem. I have pasted it over the original. But I will go through and do the directions. So it says use the space provided to respond to each statement concerning the given graph of the radical function. All right, A says domain. So quick reminder that your domain are your x values. And when we're looking at x values, we're looking to see how the graph travels from the left to the right. So this graph, it's not going to show it, but this, if it doesn't have an obvious open circle, that means this is a closed circle. And then this goes all the way to the end of the viewing windows. That means that's going to be an arrow. Okay. Oops. Didn't know my phone was still on. Sorry. It's off now. Okay. So this goes from, I'm assuming if this is, oh man, I cut off my x-axis. So let's pretend this is 2 on the x-axis. So let's pretend the x-axis is down here. When I made this snip, I cut off the x-axis. Dummy me. Let's pretend that this is -2. So this point here starts at -2. So my domain is bracket because the circle is closed. -2. So my smallest x is at -2. And then the graph continues to the right. There's an arrow here. It continues to infinity because the arrow is pointing to the right. On infinity, remember, we always use the parentheses. Okay. B says state the range. So our range is always our y's. And range y's always go up and down. So I like to say, how low does the graph go? How high does the graph go? So let me change colors here. So if we think about how low it goes, it's going to go to here, which is at 3. So it's the lowest y value on the graph in any point or any area on the graph. And this is a closed circle. So we're going to use a bracket for the closed circle. We use the parentheses for the open circle. My smallest y value is at +3, and then the graph continues to rise forever and ever, heading towards infinity. And then we always use a parentheses on infinity because infinity is not a number, exact number, it is a destination. On the end behavior, you can talk to me in terms of left side and right side. So the left side of your graph, stops at 3. So you can say left approaches 3. I like the word approaches. The left-hand side of your graph approaches 3. And I didn't write 3. And the right side of your graph, since it's continuing to rise, approaches, I'll just abbreviate it, positive infinity. So when we're talking about end behavior, we're talking about the y value. Where is it going? Is it going up? Is it going down? Since this is not an arrow, then it's, the left-hand side's approaching the y value of 3. The right-hand side is going up, 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 up. It's approaching infinity. X-intercept, this graph is not crossing the x-axis. We're pretending this is the x-axis because I cut it off when I made my snip. So we're going to say there's no x-intercept. If your graph crossed the x-axis, then you would list that as an ordered pair. That would be a point somewhere on the x-axis. It says determine absolute mins. So just a quick little definition of a min. If you have any type of curvy graph, your mins are going to be your low points or your valleys. So if this went back up, these two would be your mins. And you would list those as ordered pairs when they asked you for the mins. And then the maxes are going to be any type of mountaintops. So any place where the graph tips up, goes up. So this is asking for mins. This graph doesn't have a min. So there's no min. There's no min because there's no valley. This kind of looks like a valley, but it doesn't go back up. You have to be able to go back up. You have to go down in the valley and back up to have a valley. So there's no mins in this particular graph that I made up. Okay, so let me go over this really quick. I'm talking fast. It's been a crazy day. The domain goes from -2. This is my x-axis. I drew it in to positive infinity. The range the lowest y value is 3, and it goes to positive infinity. My left approaches 3. My right approaches infinity. This graph doesn't touch the x-axis, so there's no x-intercept for D, and there's no minimum because there's no valley. Okay. All right, 2a, state the domain. This graph reaches the end of the window, the viewing window, so we can assume that both of these ends have arrows. So this graph goes forever to the left. Domain, again, are your x's. This is how far the graph travels from the left to the right. It's going forever to the left and forever to the right, so the domain is negative infinity to positive infinity. The range are your y's. That's how far up and down the graph goes. So this goes forever down and forever up, so the range is also negative infinity to positive infinity. The end behavior, the left approaches negative infinity because it's going downtown, and the right-hand side of the graph approaches positive infinity because the right-hand side's going up, up. This graph does have a y-intercept, and it says use an ordered pair. The y-intercept is right here at -1, and that ordered pair that represents the y-intercept at -1 is 0, -1. E says explain how you know the function is increasing. You could say a couple different things, but as the x's increase, y's also increase. It's probably the best way to say that. All right, that's number 2, A, B, C, D, and E. All right, last one's asking you to solve a radical equation. We know when we solve a radical equation that we need to isolate the radical, move everything over to the other side. I made this problem up. So that leaves me with 2 times the square root of x plus 1 equals 7 minus x. This radical is still not isolated, so I'm going to divide both sides by 2. That's going to leave me with a square root of x plus 1 is equal to 7 minus x over 2. My next step, once I get the radical isolated, is to check out to see what the index is. It's an understood 2, so I'm going to exponentiate both sides. That means since this is a square root, I'm going to square both sides. If it were a cube root, then I would cube both sides, and so on. My square and my square root will cancel out. That's going to leave me with x plus 1 equals 7 minus x over 2 squared. I'm going to write this down twice to make sure I multiply this out correctly. I'm going to FOIL out the top. That's going to give me 49 minus 7x plus x squared over 2 times 2 is 4. I don't like that 4 being in the denominator, so I'm going to go ahead and multiply everything by 4. So that's going to give me 4x plus 4. When I multiply 4 times this big giant fraction, my 4's are going to cancel, and that's going to leave me with 49 minus 14x plus x squared. My x squared is over here on the right-hand side, so I'm going to want to move everything over to the right-hand side so I can factor. So I'm going to subtract 4x and subtract 4 from both sides. That's going to leave me with 0. And then on the right-hand side, I'm going to write my x squared term first because that's considered standard form. And I think this is 14x. So that's going to leave me x squared minus 18x plus 45. And then I'm going to factor. I'm almost to the finish line. This is going to be, signs are both going to be negative. This is going to be 3 and 15. Negative 3 times negative 15 gives me positive 45, and negative 3x and negative 15x give me the negative 18x. All right, I'm almost there. Set each factor equal to 0. That's going to give me a positive 3 if it checks, because we know with radical equations, we do have extraneous solutions. So I've got to check my 3 and my 5. Okay, my work is all the way up here. So let me rewrite the equation. The original equation is x plus 2 times the square root of x plus 1. We're checking to see if that's equal to 7. All right, we're checking 3. Let's do it in red. I don't have red, dang. All right, let's check the 3. That's going to give me 3 plus 2 times 3 plus 1 is 4. I'm checking to see if that equals 7. That's going to give me 3 plus 2 times the square root of 4, which is 2. I'm checking to see if that's going to give me 7. That's going to give me 3 plus 4 equals 7. That's going to give me 7 equals 7. That means 3 is a solution. It's not extraneous. And then let's check x equals 15. So that's going to give me 15 plus 2 times 15 plus 1, which is 16, and we're checking to see if that equals 7. So it's going to give me 15 plus 2 times the square root of 16. That's 2 times 4. I'm checking to see if that equals 7. That's not going to equal 7. That's going to be a lot bigger. That's going to be 23. So that means I throw out the 15, and 3 is my only solution. 15 would be considered extraneous. All right, hopefully that was helpful. This is just a help video for 5.11.